So today in 3.13, we're actually starting something a little bit different. We're going to kind of change gears a little bit, and we're going to be looking at what are called polar coordinates and polar functions. So up to this point, everything that we have graphed ever since we started graphing back in, 6th or 7th grade, we have used the rectangular coordinate system, or x comma y grid, right? The x and y axis grid that we have there. So today I'm going to be introducing you to a new coordinate system called the polar coordinate system. And instead of x comma y, we're going to have r comma theta. And the cool thing about using the polar coordinate system is we can get some pretty interesting shapes. I put 3 in there just to kind of give you an idea of the different type of graphs and shapes that we can come up with our polar coordinate system. And we can actually graph these on our calculator or in Desmos. In our calculator, if we change the mode to polar, we can graph polar functions. And it will graph things like this. My favorite is the one on the right, the one in green, which we call a rose curve. And we actually call those individual parts the petals of the rose curve. It's very poetic. So now if you want to give a rose to somebody, you can give them a rose curve. So here's some, polar function for you. It's a rose. So, and get rejected. Anyways, so we have our polar coordinates, again, as we know, x comma y. So we have our x and y. We've graphed those and put those in our grid very, very often. And it's just x comma y. Polar coordinates, again, we have the r comma theta. Now, one thing that we have to remember with polar coordinates is that, let me start this a different way. Which one, if we're looking at an x comma y and we had a function, which one is the independent variable, the variable that we would plug in, usually? The x, right? So usually the x is what we plug in to get a y value, right? Especially if we had like y equals 2x or some kind of function of x, I could plug in x and get a y value. It's actually reversed on polar coordinates. The theta, which represents our angle, the theta is the independent variable. The theta is what we're going to be plugging in. And we'll see that more on Wednesday when we do some polar graphs. But the theta is the independent, r is the dependent, r is what we would get after plugging in theta. Now, what are r and theta? So we have the picture here. So theta is our normal angle that we've been graphing. And a lot of these angles, again, we take from our unit circle. So we have our theta is the directed angle. And if we are going up, let's think about this. If I measure from the x-axis and I measure up and around, is that going to be a positive or a negative angle? If I go up, positive. How do I measure a negative angle? Going down and around, right? And that's going to be important with our plotting that we're going to be doing today. So, our polar coordinates definition. We have the origin, which in polar coordinates we call the pole. And they probably got this from, actually, if you think of our world, the sphere, how we have a north pole or south pole. And actually, if you were to look at the north pole or south pole on a map with longitudes and latitudes, it would look like this, right? If we think about this as the pole, all the longitudes going out from there, and then the latitudes are concentric circles going around. So that's probably where all this comes from, is the pole and how they kind of created the grid with the map of the world. So we have the origin, which we call the pole, and everything flows from the origin. So everything flows from the origin, and we have what we call the initial or polar axis, initial ray, which is just the positive x-axis. So we always start here, that's our polar axis, and then each point is assigned an r and a theta. The r is the directed distance from the origin to the point, and that directed distance is important. Theta is the directed angle, again talking about either a positive or a negative angle. And r can also be positive or negative, and we'll talk about what does it mean if it's a negative direction. What would that indicate? We'll talk about that in a moment. But here is a comparison with the different coordinate planes. Again, the one we're familiar with is the rectangular coordinate plane. Over here is our polar coordinate plane. And as we can see, we have all these different angles, pi over 6, pi over 3, pi over 2, and so forth, all the way around, exactly straight from our unit circle. And then these are the concentric circles that go around, and each have a different radius length. So the smallest circle in here, what do you think the radius for this circle is? What would be the length? Well, let's think about it. All the way over here is a length of, so then what would this one be? The smallest one? 1, right? And then it just goes up from there. 1, a length of 1, and then 2, and then 6, and all the way around, right? So all around the circle, the radius is the same length all the way around. And so on this circle right here, this everywhere would have a radius or a length of 4 from the origin. So let's go ahead and plot some stuff. So go ahead and turn the page. To help us out with this, I'm just going to go ahead and label each of these points. I'm going to label my first one as point A, the second one as point B, so we know where everything is. So 3, 7 pi over 6. So again, that is not an x, y coordinate. That does not mean I go over 3 on the x and up 7 pi over 6 on the y. It does not. Now, 7 pi over 6 is our independent variable. And so I like to go to that angle first. So where is 7 pi over 6? In which quadrant? So going around, that is right here, right? So there's 7 pi over 6. So that's the angle that we're at. And then where would I put my point? How far out from the origin are we going? So that would be the third circle, right? The third distance out. So I go, that'd be 1, 2, and then 3. That would be point A. So I go around, I like to go around to my angle, and then I measure out a distance of 3 from that angle. And there's our point, point A. 3 at 7 pi over 6. Does that make sense? So let's think about point B. What angle am I going to? Oh, where is 7 pi over 4? It's not marked on this. If you need to look at your unit circle, you can, but where would that be? 7 pi over 4. In which quadrant is 7 pi over 4? And where would we find it? Which one of these angle marks? Between? Very good. So I want us to pay attention to that, even looking at this here. This one marks the pi over 6 and the pi over 3. In between is going to be pi over 4. But it actually also has this one here. What do you think this angle would be, this first one? Pi over what? Very good. That is pi over 12. And so all of these distances, or actually 15 degrees, but pi over 12 is the distance of each of these. So that's 1 pi over 12, 2 pi over 12, 3 pi over 12, 3 twelfths is 1/4. So that would be pi over 4. And so we can actually count around. And that will be more important when we get into graphing. I just wanted you to notice that here. But down here, here's our 7 pi over 4. All right, what is our distance from 0? What does it say for point B? Okay, where would I put that? Let's think about this. Counting out 1, 2, 3, 4, is that my point? No, because what kind of 4 is that? This one is a positive. So how do we get a negative? What makes the most sense? Going in the exact opposite direction. So positive 4 would be going out 4 on that angle. Well, once I'm at that angle, if I have a negative r, then I go in the exact opposite direction, which should put me out right here at point B. Okay? So when we have this one is positive 4, comma 7 pi over 6, whereas this one here is our negative 4, comma 7 pi over 6. Okay? So when we do negative, we go out in the opposite direction. Let's make a note of that. Just right up here. I have a little bit of space. A negative r means that you measure, or just say go in the opposite direction. Then I want you to go ahead and try problem B. We have 4 points this time. Let's go ahead and label each of them. I'm going to say this is point A, B, C, and D. I want you to try those out. I just realized on my 2 points here and here, I wrote that as 7 pi over 6, and that was incorrect. I have them in the correct spot, but I wrote that wrong. If you wrote that down as well, that should have been 7 pi over 4. Probably did 7 pi over 6 because of the first angle was at 7 pi over 6. So this is 7 pi over 4. So again, sorry for any confusion there. That would be the correct points. All right, let's go ahead and look at these. I'm going to be calling on people to help me out. Okay, Julia, how would I plot point A? Okay, so going to pi over 3, and then what's our distance out? 5. So I go at 1, 2, 3, 4, and 5. So that is my point A. Okay, point B. Brandon, how would I plot point B? And where is negative pi over 3? Okay, so which angle labeled here is at negative pi over 3? There we go. So I know this one, again, it's been a while since we've graphed negative angles, but remember this is positive pi over 3. So how do we get to negative? Well, we go the same direction. So I went 1, 2, 3, 4 arcs over. So 1, 2, 3, and I'd end up here. That is negative pi over 3. And it actually ends up being negative angles are directly down from themselves, or directly across from the x-axis. But so we're at 5 pi over 3, and then what is our distance from 0, Brandon? 4, right? So at 5 pi over 3, going out 1, 2, 3, and 4, that would be point B. Again, going out there, that is a negative pi over 3. All right. Point C, Dean. So pi over 2, and then how do we do the negative 2? Which way are we going? All right, so we're going to be down here. But remember, it's not necessarily because we're adding pi, but this point is the positive 2. To get negative 2, I go in the directly opposite direction, right? So when I go in that angle, so I see pi over 2, going this way is positive 2, going in the opposite direction is negative 2. So that ends up being point C down here. Does that make sense, Dean? So it's not, so we just have to remember we're going, the negative R goes in the opposite direction. Okay? All right. Let's see. Ava, point D. And where is the negative 11 pi over 6? Very good. Negative 11 pi over 6 is here at pi over 6. And then what measure, where are we going? In the opposite direction. So this would be 1, 2, 3.5 positive, but I need to go that in the opposite direction. 1, 2, 3.5 would be D. Again, going in that opposite direction. Okay? So this is, again, plotting our polar coordinates. We have to pay attention to whether or not our angle or radius is negative, because that will indicate which direction are we going. Are we going in the positive or the negative direction? Now, hopefully we kind of can see that each of these points can be written in a different way. For example, if we look at question or point D here, the point was negative 3.5 at negative 11 pi over 6. But what angle did that end up being at? Point D. So could I write this with 7 pi over 6 instead of negative 11 pi over 6? Yes. But if I do, would this be a positive or negative length? Positive, but it would end up being at the same place. So that's what we're going to be looking at now, is how can we write the same point with different coordinates? And that is an interesting aspect of polar coordinates, is that every single point has multiple different points that we can do. So I want us to look at problem 2. We have this point here. It's this one here. First off, problem A, what are the polar coordinates for that given point? So go ahead and jot them down again, r comma theta. What would be the polar coordinates of that point? So what angle are you at? What is your radius out from the origin, the distance from the origin? All right, so what angle are we at again? Pi over 6. What is our distance from the origin? So is this our coordinate pair? Do we all agree with that? Okay, I want you guys, part B, is to think of what are 3 other ways we could write that coordinate pair, combining positives and negatives of both angles and the radius. So how else could we write that exact same point? I want you to think about it. All right, you've had some time to think. Any thoughts out there? Anybody want to give me one that they thought of? 3 comma what? Negative 7 pi over 6. All right, let's see if that works. So negative 7 pi over 6. So this is positive 7 pi over 6. So negative 7 pi over 6 would put me here, and positive 3 would put me here. Is that the same point? No, so let's try that again. 3 comma what? Okay. All right, let me go with what Dean said. Let's make the 7 pi over 6 positive. So that means I'm here. But then the 3 would have to be negative. And that would work, right? So if I'm here, but then I go in the opposite direction, would that put me at the same point? Yes, it would. So that's what you want to think of. You want to end up at the same place. So negative 3 comma positive 7 pi over 6 would work. Okay? All right. Want you to see if you can come up with 2 more equivalent coordinate pairs that get you to the same point. All right, try it out. Okay, let's go ahead and see what you guys have. All right. Let's start with this one that has another positive 3. What's another coordinate pair that has a positive 3? 3 comma what? 3 comma negative 11 pi over 6. Do we agree with that one, guys? Does that make sense? I go around to negative 11 pi over 6. That's what this is at. And I end up in the same place, positive 3. That would work. All right, the last one that we probably got has a negative 3 and a negative angle. And what would that be? Very good. Negative 5 pi over 6. Because if I go to positive 5 pi over 6, that's positive 5 pi over 6. So if I want to go kind of like the one I already have marked in with the 7 pi over 6, I want to go to that same location. That would have to be negative 5 pi over 6. So going this way was positive 7 pi over 6. The other way would be negative 5 pi over 6. And then regardless, we're over at 7 pi over 6, and then we have to go in the opposite direction. Now, these are the 3 that I expected you guys to have. We are not given any restrictions here. So there's actually an infinitely many more options. I want you to think about this one. So we're at pi over 6. But what if I go all the way back to here? Would I be at the same place? What would that angle be? Not 2 pi, but 2 pi plus pi over 6, right? So I've gone pi over 6 plus 2 pi, all a full circle around. Well, this is 11 pi over 6, so 2 pi is 12 pi over 6. So then what would this one be? 13 pi over 6. So I could even list this. And that would also work. And I could go around a full circle again if I wanted to. However, most often, we are given a restriction on where they want us to pull our angles from. Case in point, problem 3. So problem 3 is very similar. They ask us to plot this point and then write the polar coordinate 2 additional ways, but this time they give us the restriction that our angle has to be between negative 2 pi and 2 pi. If that had been a restriction on this last problem, I could not give that last one I gave. Only these 4 would work. Okay? So I just want us to pay attention that there are an infinitely many number of ways to write our polar coordinate pairs. using our coterminal angles. But sometimes, like this one, they give us the restriction. So I want you to go ahead and try problem 3. Part A, plot the coordinates. Plot B, just give our coordinates in 2 other ways. There will be 3 other ways. You give 2 of them. Again, angle needs to be between -2 pi and 2 pi. So just from the unit circle. First off, let's go ahead and plot our point. Zach, where would I go to plot the point? Uh-huh. One, two, three, 4. So there is my point. All right. So let's go ahead and get some coordinate pairs. Ellie, did you come up with another way that that point could be written? 4 pi over 3. Okay, so 4 pi over 3, and then -4. Good. So -4 at 4 pi over 3, that would definitely work. So 4 pi over 3 is here, and then we go in the opposite direction. There we go. Good. Jathan, did you come up with another way? What do you have? So -4 and then what? So you said -5 pi over 3? Okay, so let me think about that. And you said the 4 was negative? So the 4 is positive? So like this? That would be correct, yes. So we go, so this is positive 5 pi over 3. So -5 pi over 3 would put us there, and that would go in the positive direction, so that'd be good. All right, so yes, that would be correct. Did somebody get a different, there's one more way with both of them negative. Did anybody get that one? -4, comma. There we go, good. So that is the third and final way that that point can be written within this range that they gave us of -2 pi to 2 pi. All right, good. So that will finish us up for today.